So in the previous session, we were talking about Prometheus configuration. We have done that. So now we need to configure Grafana. Okay. So to that Grafana, we are going to add a data source as a Prometheus. Okay. So we need to install it. I think we need to let this three and this one also. So Grafana, for Grafana, not only the Prometheus, it can be application also can be a data source, or it can be database also can be data source, like you have any MySQL database or any database you have, and you want some information in the Grafana dashboard of database related things also. You can configure data source as a database also, or Prometheus. Prometheus is what it is doing. It is collecting all the metrics, and that data it is collecting and storing in the Prometheus server. And that server information we are giving in the Grafana as a data source, so that it will collect the information. It will give you the in the visualized dashboard. So like that, not only Prometheus, you can add database as a data source or application as a data source, like application functionality. Whenever that application is down, that is also you will get to know whether how it is accessing, what is the network traffic of that application, everything you can configure. So here this, so first I'll connect to this Linux server. Okay, so same way how we deployed Prometheus, same way we can use the Grafana also. Okay, the same procedure we can use it. Now Helm list, if you see the Prometheus, the last time we deployed, it is through this machine with the help of Helm command. And same way, if you search Helm search Grafana, so it will connect to the stable repository and it will show us the Helm chart of that Grafana. Okay, so now again here also we need to do some modifications in the values.yaml file. As I said, this Helm chart, all these values are defined inside the values.yaml file. Okay, so whatever you define inside the values.yaml, it will pick up. It's like a variables. So variables has been configured inside the values.yaml file. So we need to do little bit modification to this values.yaml file, and then we are going to use same way like what we have used for Prometheus. So modified values.yaml file will give as a reference to take it instead of the default values.yaml file. Okay, so I hope you remember like Prometheus. um Grafana Helm chart. So whatever the objects it is going to create, if you see in the templates, so what are the objects it is going to create, this many objects, all these objects values, if you go to the deployment.yaml file, all these values it is taking from the values.yaml file. Okay, you know, right? I hope you guys are knowledge about scripting. So what we'll do scripting, instead of hard coding values, we will give it as a variable. Okay, it will pick up that variable and that variable name we will give here. Same way In Helm charts, all these values we can define in the values.yaml file, and we will tell here that go and pick it from there. So instead of modifying all these files, we always go to the values.yaml file and we'll change there. Okay, it will be easy in real time. It will easy for automation purpose. Okay, we don't give hard code values over here. Okay, so all these values, any file you take, all these values it is taking from the values.yaml file. Okay, this is PVC to create a physical volume claim. Understood, right? So now we are modifying that values.yaml file. If you see here, this is the values.yaml file, and here it will tell replicas equal to 1, and a deployment strategy type is rolling update. So from here it will take. Okay, so this readiness pro path image, this is the image location, everything. Already this I discussed in the Helm chart session, right? So all the values will be collected from here. So now I'm going to modify few things inside this. Why? Because if I check type, uh, yes, this is showing as a cluster IP. Cluster IP means what? Internally it can communicate, but I want to access it through the browser. So it should be node port. Okay. So or it can be load balancer IP address. So I'm going to configure it with the node port, so that by taking any of the node port node IP, I can able to access this Grafana through the dashboard, right? And I'm going to give the port also here, the node port some 32,300 something like that. I'm going to give. This is the one thing I would like to change. And admin password is disabled here, means when the Grafana dashboard is going to open, we need to provide the admin dashboard password. So here, what are the password? You can set it here. The same password you can use to log into the Grafana dashboard. And another thing is persistence. Here, persistence volume, enable persistent using persistence volume claim. So if you already uh, in real time, you should always go with the persistent volume claim. You know the difference, right? Persistent volume claim, from where it will get created, physical PV. So you should have physical PV. How you are going to get physical PV? Physical PV you are going to get depends what kind of cluster it is. Whether if it is an AKS, then you might use Azure file storage or maybe Azure disk storage to create as a PV, and from that PV it will create PVCs. Okay, or if it is an NFS, or else if it is an AWS, then it can be AWS EBS. Okay, or it can be NFS over there, or a lot of other storage options are available. So it depends upon what storage you are using to create physical PV. From that physical PV, it can create persistent volume claim. Because here Grafana, if you are not using persistent volume claims, then the Grafana pod, if it is restarted, deleted and created, the data will be erased. Why? Because by default it will take mtdir. So you guys remember mtdir means what? Locally, wherever it got deployed, in whichever workload it got deployed, it will create a volume and it will mount it. But when it is pod is deleted, the data will also will be erased. So you are not going to get the data. So that's why the recommended is PVC. But in this scenario, I'm not going to use any, because again I need to configure PV, PVC, all these things. You can do that from your end R&D. So if you have any PVCs available, then you should enable here. Okay, enable true. Then it will take physical volume claim. Automatically it will try to create. But before that, you should have PV should be ready. As I said, if you are claiming for PVC 10 GB, PV should be there with 10 GB or more than that. 10, 20, 30, it will take that complete PV. So here in this Helm chart, they are already defined to create PVC also. See here in the templates, PVC. So they have a YAML file to create PVC. Okay, but there already should be PV should be there with the size whatever they are defining. If it is not there, then PVC will not create. If the PVC will not create, then your pod will not come online. When in case if you uh, make persistent volume enable equal to true. If you don't enable for practice purpose, then you can use MDDIR by default will take, and as of now you can manage it, but in real time implement, definitely you need to configure PVC, PV, all these things. Okay, so these are things I'm not going to change persistent volume to enable true, let it be false only. So here, where is this one? So this is a Helm inspect. Okay, so Helm inspect and this one. Okay, values. I forgot the command. Yeah, Helm inspect values, and this is the Helm chart. Okay, redirect the output to the /tmp / Grafana dot values. So it's like a cat command, but directly we are viewing the values.yaml file from the Helm chart. No need to clone locally, available locally, and that output we are redirecting it to the Grafana dot values.
So Grafana.values, it's a text file, Praveen.
Sorry.
Grafana.values, is it a text file?
Yes.
Okay.
You can give any name. So this, for my reference, I'm just giving Grafana dot values. It's a text file only. You can give any name. Okay, only you
Okay.
can just give grafana.txt or anything you can give. Okay. So I'm going to modify this with the VI editor and open this file and just search with type and type here service. The naming convention, make sure that it's correct. Okay. So here case sensitive is compulsory. Node port, N caps, P caps, and then IP address, node port 32325. Okay, this is a port number I'm giving. So here in the node port, P is caps. Okay, so if you give any case sensitive, then it will not accept. So this is the one, and another one is admin password. Where is that? So let me search for. Okay, here. So admin password, give any password, strong password, cloudfreak@123. This is the password I'm giving. Okay, that's it. And as I said, if you want to change, so persistence here, if you see enabled is false is there, then you need to make it as a true. Okay, then if you have a PVC ready with you, then this PVC will get created from that PV. Otherwise, it will not get created. Deployment will be failed. So now save it. Now install this one. So Helm install stable Grafana. This is a stable Helm chart and hyphen name. This is a release name, like whatever the release name for this Prometheus. When you type Helm list, because through Helm you are installing. So Helm should have that record what you are doing. So this is the release name. So you can give anything. I am giving Grafana and hyphen values. We are telling that take these values instead of default values. And then I want this should be in a different namespace. Prometheus in different namespace and Grafana should be in a different namespace. And this is a different namespace. Okay, it's done. And you see here, these are the things got deployed, and this is the name of the release name. And inside this namespace, it got deployed. And whatever the components were inside the templates directory, all those components has been created. Okay, cluster role, role binding. Okay, config maps, deployment, pod got created, service got created, secrets, all is got created. And if it is saying this is also deprecated, it seems the Helm chart, and this is the new Helm chart they are providing to us. Okay, so if you see get your admin user password by running this one also, you are going to get that the password. Means if you don't configure in the values.yaml file also, you are going to get by using this command. Okay, so let me log into the master server now. CentOS. Okay, so let me copy this. Okay, I should use as a Pavin user account because this user doesn't have access. Okay, so if you see what are the password was assigned, if you don't assign any password, if you give here, it will give some default password. Okay, so now let me see kubectl get pods -n in the Grafana and kubectl get all -n Grafana. All means all resources which are created in the Grafana namespace. So these are the resources. Okay, and this is the service. This is a 32325 is a IP and type is node port which got deployed. So now I can able to access this Grafana by using any of the public IP of my node and using this port. Okay, so now let me go to my any of the worker node, take the public IP, 32325. So this is a Grafana dashboard. So admin and password is cloudfreak@123. Okay, so here you can see tutorial data source and dashboards Grafana fundamentals. You can go through it. Okay, and you can go through the documentation. See, even this Grafana you can install in your local laptop also. Let's say you have desktop also installed in your local laptop if you want to test it, and in your Windows also you can install. You have Windows version of Grafana also, and you can use an IP localhost and the port number of that Grafana. You can able to access it, and you can give the data source. That way also it can work. No need to have any Linux machine or Prometheus. Different ways it can be used. Okay, so now here you can create dashboards and you can get the docs also easily. You can see how you can create it. And this is data source. Add your first data source. This is as of now independent. It's not connecting to any Prometheus now. It's deployed, but it's not. We did not configure anywhere that you should get the data from the Prometheus, right? This is an independent service now running. So here add data source. So now here it is checking where is your data source. So InfluxDB, Elasticsearch is also one of the kind, like same like Prometheus, and see SQL database, PostgreSQL, Microsoft SQL. If you want to monitor, so for example, in database we have tables, rows, columns, a lot of things are there. If you want to monitor that one also, you can configure here. Okay, so CloudWatch, Azure
So,
Monitor.
Praveen, I mean, here, let's say, like we have deployed a pod, okay, so DB, iSQL. So
Hmm.
how do we configure? So do we give here the pod IP address
If the
or
data
service?
no, so database always is having an IP address.
Yes.
Okay, so to access that, you give that IP address, not the
Oh,
pod IP address. Already we discussed that pod IP is randomly it is going to change. So
true,
for your
true, true.
database, you might be
Yes.
configuring some node port or load balancer or cluster IP, right? That IP
Correct.
address you need to configure here.
Sure.
So multiple sources are there to configure your data source. So we are configuring Prometheus. Okay. So here we need to give the Prometheus IP. Now here HTTP. I am going to give Prometheus is running on this machine. So it can also it is also configured with node port and kubectl get svc-n Prometheus. SVC means the network services it will show, and this is a node port I configured, and 32323 is the port number, but I need to give the public IP. So let me take the same public IP here because this is a node IP, right? So I can use the same IP and 235 32323. Okay, and here we are going to give browser. That's it. Save and test. It's trying to reach, fail to fetch. Oh, sorry. It is double HTTP. Data source is working. Okay. Clearly we can understand, okay, it's connected to Prometheus and it is working because this IP is a node IP. So Prometheus is also running on Kubernetes cluster and this is also node port. So you can use any node IP address, and what are the port it is running. So I was using the same IP for accessing Grafana and same IP for Prometheus because it's both are running on node port service and ports are different. Okay, so now this is done, and now we can go to the home. Here this is complete, data source is complete. Now we can create a dashboard here, add a new panel, and mm, here we can, the metrics can be added. Okay, so what kind of metrics? CPU, okay, container, CPU load, average. So these metrics will be available based upon your data source. If it is a database, this metrics will be different. If it is something else, this metrics will be different. So this metrics is driven by your Prometheus. So CPU system, CPU container, CPU period. So all is related to the containers. So if I check this one, what are the pods it is running, it will show you here. Okay, so format, how you want the time series,
I mean, does
we can.
AWS CloudWatch support this Kubernetes cluster monitoring?
Yes, previously when I was showing you the source, data source, AWS CloudWatch is also available. If you see
Okay.
here, slowly it is showing now this container spots information.
Yes. Yes.
So see all this information. So these kind of metrics you can configure Okay, and you can visualize your data. And
And we can export these data into log format, right? Is it possible?
yes, again from here you can configure alert manager so that you will get alerts whenever if there is something is down, okay, or something is problem. Lot of things are there. You can go through this Grafana dashboard. Lot of things you can configure, and if you don't want this dashboard, uh, you will get some other dashboards also, means viewing. If you don't like this dashboard, you can get different dashboards also for here. I think that um, save dashboard, new dashboard, test. Okay, here you can see import, right? So this import option, so Grafana is giving you a lot of dashboards. So you can go and check which dashboard you like, and those dashboards is having one ID. That ID, if you give it here, it will go and connect to that, and it will import the dashboard. Means the view, like how we call it as a themes. If you change the themes, the same way here the dashboard view. If you don't like this default dashboard, you can get some different dashboards also. Okay, if you see here right side, these are different dashboards. You can have a view, and whichever dashboards you like. uh, I think where is the code of the dashboard? Okay, so this is the dashboard ID. Copy this ID, and if you give it here, so this dashboard will be imported here. So if you give that ID, this dashboard will be imported. So like this you can check. These are the images, how it looks like, what kind of things you are expecting. If it is Kubernetes related, then this is a node name, OS version, Docker version, all this it is showing. So for Kubernetes, I think it will be good to have this dashboard. Okay, so that way also you can import it. Where is that? So which data source is there? Based on that, you can configure this. This is a data source and import. So namespaces, if you see, 5 namespaces. So previously this all things was not showing. Because of this Kubernetes dashboard, it's collected respective information, and total pods are 20. PVCs are not available. Cluster age, recently I configured, right? I think on Saturday. This is the cluster age, and best efforts pods, and these are the node names, memory used. So this dashboard is suitable for cluster. That's why I imported this one. So based upon what is the purpose, what is your data source, based on that we can have our own dashboards. Okay, so I did not configure any of these things. Automatically it configured, and it is showing all the information.